So I've cleared away some of our scratch work, and I think I'm about ready to write a proof down because we figured out what the deltas should be, and I think I have the right logic. So let's go for it. Here's our proof. Well, I have to show that for every epsilon greater than 0, there's a delta greater than 0. So I should start by saying let epsilon be greater than 0. That doesn't say much, but it kind of does. It establishes that epsilon is arbitrary. Now, based on that epsilon, let's also let delta be the thing that we realized it should be. It was a weird looking expression, but we kind of have the logic in our heads to figure out how we're going to get there. The minimum of epsilon over 5 and 1, whichever number is smaller. Okay, fine. Now we have to show that if this statement is true, this must be true. Fine, so let us assume, indeed, that this is true. Let's assume it. We're not going to explain why it's true. It's an assumption. I'm going to show that that assumption leads to this conclusion. Let's give it a try. All right, well, if I'm assuming that that's less than delta, based on the delta that we've just defined, I guess we're saying two things then. If it's the minimum of two different numbers, and x minus 3 is less than it, then this would have to be less than this, and it would have to be less than 1. Okay, well, those two inequalities actually kind of say two different things. Let's look at them one at a time. This inequality, what does that mean? Well, if x minus 3 is less than 1, then what that really means is that x is between 2 and 4. Well, if x is between 2 and 4, then x plus 1 is less than 5 and 3. And that means that the absolute value of x plus 1 is, comparing these numbers to each other, 5 being the bigger one, x plus 1 is less than 5 in absolute value. How are we going to use that? Hang on, let's hold on to that for a second, and let's look at this inequality. Now that I know that x minus 3 is less than epsilon over 5, well, that indeed implies that, by a little bit of arithmetic, 5 times x minus 3 is less than epsilon. But because of this inequality here, that means that this x plus 1 times x minus 3 must be less than epsilon, because this is smaller than 5. Great! I think we're about done here, because a little bit of algebra finishes this for us. We have x squared minus 2x minus 3 less than epsilon. But let's say what we really should say. Let's make our point clear. Let's break up that minus 3 into a plus 5 and a minus 8, so that we're really saying what we needed to say. We have indeed shown what we need to show. We've finished the proof. We have shown that for every epsilon greater than 0, there is a delta. It is this one, such that this assumption leads to this conclusion. Our logic all went this direction. Remember, we worked it out backwards, but our proof ultimately has to be written down in a way that can be followed one step after another in a logical progression. And we finished it.